Welcome back. We're still working on the problems in test 2 review. We're going to start in this video with problem 21. It says given the graph of a one-to-one function, sketch the graph of its inverse. Well, an inverse function is reflected across the line y equals x. That means that all x's, an inverse switches x and y values. So the graph of these would just switch the x and the y values. So this one, when we change 3, 3, it's still going to be 3, 3. It doesn't change. When we change this one, it's going to be 0, 2. When we change this one, it's going to be 0, negative 2. When we change this graph, it's going to be negative 3, negative 1. So to graph the inverse function, we just need to change the values by switching the x and y's. So 0, 2, 0, negative 2, negative 3, negative 1. Okay, so our graph would look like this. Okay, it would be a mirror image across the line y equals x. It's a mirror image across y equals x. Okay, so that's how we graph the inverse. Just switch x and y values. All right, that works if it's one-to-one. This is one-to-one because any horizontal line crosses only once. All right, on to problem 22. Problem 22 states, determine algebraically if the two functions are inverses of each other. All right, so to be an inverse function, they have to be composites that equal x. So this composite has to equal x, and this composite has to equal x. In order for that to occur, that tells you that they're inverses. So what we want to do is we want to take that composite and see if we get x. Now, if you don't get x the first time, you can just say no. If you get x the first time, you have to try the second time and see if you don't get x. So you have to try both if you get one to be x. If you get the first one to be not x, then you can stop there. So let's take a look at this. This is saying f of, let's plug in g. G is x over 3 plus 4. Okay, so then we're going to take the x plus 3 over 4, we're going to plug it into x. So 3 times x over 3 plus 4 minus 4, and then we're going to simplify that. Well, we need to multiply by 3. 3 times this is 3 over 1 times that, so that's 3x over 3 plus 3 times that, which is 12, minus 4. So we're going to get x plus 8. That's not equal to x. So these are not inverses. If you had gotten x, then you would have to try this one to see if you could get x out of that one as well. All right, so that was 22, how you determine if they're inverses. 23 says algebraically determine the equation of the inverse. How do you actually find the inverse from this? Okay, there's 3 problems here. We'll start with 52. 52 says find the inverse of this problem. Now the steps are to finding the inverse is to write the equation with a y instead of the function, switch the variables, so x, interchange them, so y becomes x and x becomes y. Now we're going to solve for y. So you interchange x and y, and then you solve for y, and that's going to be your inverse function. So in this case, we would add, or we would subtract 1, and you divide by negative 3, so it'd be negative 1/3 x plus 1/3 equals y. So our inverse there, which would we use inverse notation, would be this function here, negative 1/3 x plus 1/3. That's our inverse for 52. Let's do 53 now. as a practice. So 53 states y equals x cubed minus 1. So interchange x and y. Circle the answer here. Interchange x and y over here. So x equals y cubed minus 1. Solve for y. So we add 1. And we need to get rid of the cube root, or cube. So we're going to take the cube root, actually. We're going to take that cube root of both sides to get rid of the cube. So our answer is going to be the cube root of x plus 1. So we would write that in inverse notation. We're still using f of x, so we go f with a little -1 for inverse. It's going to be the cube root of x plus 1. Alright, okay, the final one, 63. It's going to be somewhat of a challenge because it's a fraction. So you're going to have y equals 3x, let's just double check, 3x over x plus 2. So this is a little bit of a challenge. We want to switch x and y's, so we got x equals 3y over y plus 2. Now you're going to need to try to get these, I don't like fractions, so we're going to multiply this by the denominator. Both sides actually. We're going to multiply both sides by y plus 2. Over here they're going to cross out and just leave us 3y. Over here we multiply, we're going to get xy plus 2x. Because you multiply x times that and x times that one. Alright, now we need to get, we're solving for y, so we need to put the y's together, so I'm going to move this over here. So I have 2x, I'm going to subtract the xy. So I'm going to get 3y minus xy. Now this is the trick of solving this. We need to get y by itself, so we have to actually factor it out. We factor out the y and we get 3 minus x. Okay, and then we just divide by the 3 minus x to get the answer. So this is going to be y equals 2x over 3 minus x. So that, using function notation with a little -1, we do the exact same function. It would be 2x over 3 minus x. This would be our inverse. And if we weren't sure, we could take the composite of the two. If you want to make sure, you just composite the two things together and see if you get x both times. Alright, and that's the end of the review. The review ends at 23. So that's the final review video.